Hi, everyone. We're going to get started in about 20 seconds here. Today, we'll be talking about monitoring LLMs in production using LangChain and WhyLabs. I'm Bernice Herman. I'm a senior data scientist at WhyLabs. And if you are interested in following along, either with the slides or the Jupyter notebook, highly suggest the notebook. At the bottom, you can see the links there. And then we'll try to get the links pasted as well. And in the meantime, shout out kind of where you're coming from, what city or country that you're in, and what the weather is like. The weather is beautiful here in Seattle today and the last couple of days. All right. We'll get started. So some introductions. So who am I? I am a senior data scientist at WhyLabs, and do lots of fun stuff, I guess, here on the right. The other role that I have is a research scientist at the University of Washington, where I do research on exactly what I like to think about across both jobs, and that's really evaluating machine learning and LLM models in real life situations and use cases. So we're going to talk today about, I think, a important version of evaluation, really monitoring LLMs in particular. Okay, so what do I do at WhyLabs in particular? So WhyLabs is this, has a number of different products, including two open source packages, one called WhyLogs, one called LangKit. We're going to focus on LangKit today. But kind of within this larger observability system that I like to view in this way. So you have lots of different data coming from different sources, and we would like to understand what's happening in that data in a way that is kind of privacy first. And so the way that we do this is we use WhyLogs, which is a kind of AI telemetry agent. So we can do something like statistics on top of that data in your environment. So we actually don't see your raw data. We capture high-level statistics, and only those high-level statistics gets passed on to our observability platform. And from there, we can do things like anomaly detection, visualization, machine learning over time to understand what kind of issues are going on, to do monitoring and alerts. And from there, you can do lots of things. So you can alert the engineers, the data scientists, the business team members of what's happening in your model, potential issues that are happening in your model, or directly trigger pipelines within your system. Maybe automatically retrain your system at a certain point, or send your data to do some sort of human in the loop process, or do some sort of guardrailing that allows you to take a deeper look at the data, or prevent the user from seeing some information that might be harmful or not in line with your goals. So where do I fit in this? Well, I work largely on anything that touches the statistics and machine learning parts. And that's actually three parts. The slide needs some updating here. So one is WhyLogs. So this is this AI telemetry bit. So it's our open source Python package that has a lot of kind of heavyweight statistics in it, in capturing those metrics and statistics on your data in a way that's privacy first. And then LangKit, which is another open source package that we'll talk a lot more about, including the next slide. And then finally, the side of things where we do the anomaly detection and the monitoring, because we have a lot of machine learning that we use and statistics that we use to do so. Okay, so now a little bit about LangKit. So In addition to just capturing statistics, which is very important, these things get really hard when you're using text and using LLMs. I mean, the reason for that is that the sorts of metrics and the sorts of things you need to think about are just much more difficult to capture. So, for example, if I have numerical data, if I have a regression model or something like this, the outputs are numerical often. And so things like the average and the median and maybe more complex statistics on top of those numbers can really capture and summarize what's happening in the system to the point that we might be able to look at those statistics and generate helpful alerts and anomalies, and even kind of you looking at that and coming up with actionable next steps. That differs quite a bit for text, just because text is hard to summarize and describe in aggregate. And so what we need to do here is come up with new metrics, some metrics that are more kind of semantically meaningful, that tell us something about the data that can be helpful and for us to use. So if you look here at this example of what we kind of expect to see for an LLM, which are a number of prompts, so text coming in, and then responses. And those responses often are text themselves, but could be other sorts of generative output like music or code or images or so on. What we want to do here then is capture different metrics, more advanced metrics about the inputs and the outputs that pertain to a number of different categories. So in LangKit, we think of these categories as quality, sentiment, security, and governance that you see here on the bottom. So what sort of questions does this answer? We kind of want to answer questions like, how were my prompts and responses written? Are these kind of very advanced levels? Is this with an academic or a medical tone, that sort of thing? Are my prompts and responses readable and accurate to their design intent? So something about reading level or kind of how interpretable is the text. And then we might want to know the relationship between the prompts and the responses themselves. So if you have prompts that are about one topic and responses that are about a completely different topic, that in aggregate is going to be certainly a concern, because this might tell you that our LLM isn't responding on topic in a way that we would expect it to. And then, so that's quality, but then we can look at things like sentiment. So many of you may be familiar with sentiment from natural language processing, right? So this often is some measure of positivity or negativity in the language. And this can be helpful for a number of reasons and applications. So certainly if you have kind of a customer service chatbot or anything related to this, the question is my LLM responding in a way that's in line with our expectations for the type of tone that we expect our LLM to be using or our users to be using toward us? Does my LLM talk about or summarize things that I explicitly don't want, or use tones that I don't want? So this is something maybe more related to toxicity. So are we using toxic language? Is the LLM using toxic language? And there's a number of questions related to security. So is my LLM receiving jailbreak attempts? So jailbreak attempts are often prompts that are sent to the LLM, attempting to get the LLM to respond in a way that the designers of either the LLM or the application surrounding it, which often we are, in ways that we did not intend. So if I have an LLM that isn't intended to give kind of advice for doing criminal activity, I want to know, are customers or users of my product or tool asking questions that are attempting to get around that? And maybe if they ask directly, the LLM is correctly saying, no, I won't give you a response to that. But there's lots of many sneaky jailbreak attempts and approaches to get around that. And we certainly want to know that that's happening and with what frequency, and if that's increasing over time or decreasing, or specific instances of it. Is my LLM leaking sensitive information? So we know that any machine learning model that gets trained on massive amounts of data takes in and often memorizes little bits of that data, just because there's so many parameters in such a model. And so that can include things like people's social security numbers or phone numbers, or medical diagnoses tied to a person's name or something like this. And what we don't want to see is that our LLM is outputting a phone number or outputting a social security number or any of this stuff as a response to a prompt, certainly to a prompt that didn't ask for such a thing, but maybe not at all, even if you do ask. And then on to governance. So I want to know, is the information reaching my LLM in line with policy, right? I want to know how much of this data is leaking either in the prompts, so customers passing on maybe private information that they shouldn't have, or certainly information that's coming from the LLM to the customer. So yeah. So now, if you haven't already, I'd love to hear a little bit about you. So that was all about me, all about the products that I work on at WhyLabs. I'd love to hear a little bit about you. Pass in your name, your company and role, or if you're job hunting. And then importantly, how many models have you deployed in production? Has your organization deployed in production? And if so, how does your team find out about issues in your model? And this can be either an LLM or a machine learning model in general. We'll talk a little bit today about kind of the differences between those two. I mentioned it already a little, but I think any of that experience is really helpful, and getting some context about where you are on that will be really helpful. Right, I'm going to take a sip of water here. Okay, thank you, Yannick. Let's go forward to LLMs and generative AI, and feel free to join in the chat later if you'd like. Okay, so at this point, I don't think I have to do the sort of why generative AI or LLMs are important. I think we see lots and lots and lots of news about them, and probably the impacts of them in our personal lives in addition to our kind of business lives. But one thing that is worth pointing out is the difference between generative AI and LLMs. What do we mean when we say some of these terms? So the thing to point out here is that while what we talk about most often these days are LLMs and language models, that is not the full extent of generative AI, right? We have code, we have images, we have speech generation, we have video, 3D, and other. This can be really helpful. So we're going to focus today on text, but many of the things that we're going to talk about today apply much more broadly, not specifically LangChain, although I think it's worth noting that even in the production of many of these other types of outputs, the input is often still text. So often understanding text and using LangKit, the WhyLabs tool, will still be helpful for the input of the model, even when it's something different. But generative AI has similar challenges. Okay, so as we mentioned before a little bit, when we're talking about LLMs, we're going to assume that we're interacting with prompts and responses. So a prompt being some text input that asks a question or starts a conversation in some way, and then a response to that question, keeping that prompt in context, right? So you often have to look at these two together, and it's also helpful to compare the prompt and the response to understand the quality of the response. So the challenge for language, as I already mentioned, is that there's just really complex tasks and goals. So for example, this might be a response. I think this in particular happens to be a news article, but let's say it's a response from an LLM. Um, it's really difficult to understand this. Maybe we can do some simple things like count how many words there are, count how many characters there are, so on and so forth. But what we might want to do in understanding whether or not this LLM is hallucinating or giving factual information is understand, in this example, how many different specific entities are in this text. So named entities are things kind of like proper nouns, so people, dates, organizations, that sort of thing. And having tools that track this, having some metric that tells us, okay, these are the named entities or these are the number of named entities can be really helpful. So then we get to other challenges. So named entities is something that in natural language processing, people have worked on before LLMs. That's not quite the case in some of these other challenges. So this is an example of a hallucination. So this is a prompt that you see at the top. I'm asking to summarize this article, and then they pass over an URL. And then the LLM gives a response to this. Um, and we don't quite know if this response is a good response. Does this describe the article or not? Well, in this particular example, the reason that it made its rounds on the internet is that this article doesn't exist. This was just a URL that's completely made up. If you copied it over into your browser, it won't work. There was no New York Times article with that title that day. And so what this tells us is that the LLM looked at the words in the title, right, and the URL. So ChatGPT prompts to avoid content filters, and took that and generated a hallucinated a whole description for the article, right? And so the question is how do we think about these things statistically? How do we find them? How do we monitor for them? Because LLMs are certainly capable of doing something like this. Okay, so now that we've talked a little bit about LLMs and generative AI broadly, let's think about evaluation, monitoring, and observability. So, evaluation is a term that you're most likely to have seen. It's something we all think about and learn kind of as we're training as data scientists. And evaluation is about understanding the quality of a model. So, for this model here, well, for a model, often you might answer questions like, how well does this model perform on test data that I've held out from my data set? And what you need for this is often labels. So you need to understand, well, what is the right answer? What is a ground truth label that we have? And then we can use that to understand, well, what percentage of the held out data does my model get correct? This is what we often think of as accuracy, or many other questions about, for example, recall or precision, or many other metrics that can be helpful to evaluate. But the key for many of these is that evaluation is about understanding, is there a problem, and to what extent is there a problem with the quality of our model? And it requires us having some ground truth, some right answer to compare our model's performance to. This differs when we get to the world of monitoring. So evaluation works really well in experimental settings and in settings where we can get ground truth. But often in a production use case, we have an evolving data set. So we see this here. On the left, we see an experimental machine learning setup. We have our trained data set, we have our test data set. But for production machine learning, we often have, let's say, a daily data set, or every 5 minutes, we're collecting new data, or every week, we're collecting new data. And so we might not necessarily have labels or ground truth. And instead, what we have is change over time. And monitoring is about kind of analyzing changes in quality over time. And what this is helpful for is one, noting when these issues take place, right? So if I know that our model has been pretty similar in the responses or the distribution of data that we've seen until 3 days ago, where things changed drastically, this might tell me a number of things. Maybe there's been a change to the model or a change to the outside world or some sort of seasonal pattern or sale that's gone on. But this now starts helping us to get down to what could the issues be. And those issues could extend beyond the model. I have a question from Marcia. Hopefully, I'm pronouncing your name right. So this is a really good question. It's once you use held out data to evaluate, is it then unusable going forward and you need to get more? So this is true theoretically. So this is what we call adaptive data analysis. So the study of, well, if we're holding out a data set and we've now evaluated using this model, or sorry, using this data, um, won't we leak some of the knowledge that we've gotten for this data into the decisions that we've made, maybe into the model itself, so on and so forth. So theoretically, you would like held out data that like hasn't been seen or evaluated on before, because what could happen is a number of different issues. So I think the main concern is that you've looked at the results of this, and any changes that we've made to the model are dependent on those results. So the worst case scenario is that we, test on, or sorry, we train on test data. That would be bad. Then we're not really testing our model and being able to generalize on new data. But assuming that we're not doing that, it can be okay to, let's say, look at the same test cases every week or every time they do a release. That can be okay. But what we want to make sure is that we're not making changes to the model, including kind of individual personal changes based off of those results. So for example, if we have a basket of data that we're using over and over and over and over again, and we're taking that information and tweaking the architecture or hyperparameters for our model, we're going to start to get away from generalizing because there's information that's feeding back. So all of that said, that's kind of the theoretical speech about this. There are many, many, many cases in the real world where people have done some sort of data leakage of this form. And it tends to generally be okay. Is it the best thing to do? Not necessarily the case. But I think there are some interesting kind of studies about, well, we do this in practice a lot. Kaggle competitions, any sort of these challenges, these sort of kind of regular benchmarking tests, and they don't seem to affect the models as much as we theoretically think they would. So if that's all you have, I say absolutely go for it. But there's a lot of theoretical work that would say that you probably shouldn't use that held out data. All right, so going on from monitoring, which we're looking at quality over time, let's go over to observability. So now, instead of just looking at our whole data set across many rows of data over time, we might also think about observability, which is pinpointing issues within your system. So now we're looking at maybe multiple points within the same data point that we're trying to run our model on. Maybe before we do some feature engineering, or after we've done some transformations and after we've done predictions, we want to capture statistics about our data. So not only can we understand overall in time when there's been changes to our data, but where in the actual process of our system do there seem to be changes injected? And this, I think, is the kind of holy grail of really understanding your system. pinpointing where it may be within the system, in addition to just time. And that's observability. And that's what we strive for at WhyLabs. Okay. So the problem is that capturing signals in your model quality is very difficult. So I talked a bit about statistics. So even capturing the right statistics can be really hard. So certainly we can do things like a mean and a standard deviation or median, and other kind of ranked things. But this isn't quite enough. And there's many reasons for this. But a lot of this comes down to tail events and understanding kind of rare cases. So it's not quite enough to understand what the average case is. When we're monitoring, what we're trying to understand more is what are these rare cases and when are they happening? Why are they happening? So that we can find the issues that are causing these more rare cases and predict kind of issues before they come up in the future. So statistics gets us one place, but doing more advanced work. So we use data sketches in our case, which is a kind of advanced technique for capturing a mix between statistics and a sample with kind of accurate error bars. This is really important to us. But going beyond statistics, especially as we kind of talked about for text, we need to start thinking about other measures. So one measure are things like data quality. So all of the stuff that we talked about for text, things like capturing the sentiment, capturing the presence of toxicity, or many other kind of text-specific metrics. There's also performance metrics. So if you are lucky enough to have some ground truth data for your data over time, maybe because you invest in getting some labels, and it doesn't have to be all of your data labeled, but maybe some small proportion of your data labeled, or you find some other kind of proxy metric, or you just happen to be really lucky and work on a problem that naturally produces labeled data over time, then you absolutely want to use that. And that's another way to start understanding your model quality. But finally, sometimes we don't have any of that. We might have some statistics about the inputs and outputs, but we need to augment this with business KPIs or things like this. So it's not directly tied to the model itself, but it's tied to the impact it may have on customers, right? So maybe I'm using a particular model to interact with customers, and I find that customer engagement with my chatbot is much lower. This isn't directly tied to any responses of the model, but we, with enough patterns, we may start to rely on this to better understand our model quality. Okay, so finally, we're going to talk about how we combine with LangChain and LangKit, the tool that we use, how that works. So we'll get to some code here, but I just want to give some context up front. So first, we are, as I mentioned, a big fan of open source software. And we think open source software is crucial kind of in the space of AI in general. Many of the tools that we use in the AI space are open source or rely on open source software. And for fun, I have some pictures down here of different open source or open initiatives and tools that we use in the AI space. So if you can name any of those, feel free to do so in the chat. But the commonality that we have between, well, we have many commonalities, but the commonality that we have between LangKit at WhyLabs and LangChain are that we're both open source and that we can work together easily. Okay, so let's learn a little bit about LangChain. And I would personally describe the benefit of LangChain is to reduce the the engineering boilerplate that's needed to interact with LLMs. So if you've made an application using LLMs, there's a lot of interaction that you have to do through APIs, and there's a lot of boilerplate that starts to grow as you make more advanced applications that rely on LLMs. So, for example, it's one thing to pass in directly a string of text from a customer to your LLM. I would not suggest that. Customers say crazy things, LLMs say crazy things. So then what you're often going to do is you're going to build some templating about the prompt, both to kind of filter through what the customer says, but also to generate the outputs that you want. It's our job as creators of applications that use LLMs to form kind of what the customer is saying or what the user is saying into a question that's better suited to get the response that we know they're looking for. So often what you see are things like templates and retry logic and lots of this sorts of stuff. And LangChain makes it really great to build applications through this sort of composability so that you write templates. You can use those templates to call LLM. You may be able to, you may need to call multiple LLMs, that sort of stuff. I won't go very far into the LangChain framework. There's many tutorials and things online on LangChain specifically, but there's a lot of different concepts and structure that's really helpful here. So these are some major components in LangChain. So models, we've talked quite a bit about LLMs and other models such as text embedding and so on. Prompts, so different ways to structure a prompt, different styles of prompt. There's user prompts and system prompts and templates for those prompts, et cetera, et cetera. Indices, memory. So certainly when we think about LLMs, one example that comes to mind are things like chats. So in those cases, we have a message history. We have not just one prompt and one response, but we have a series of prompts and response that all kind of live in the same context and require some memory. Then we have the chains themselves, right? So again, we're calling multiple calls to the LLM. We also could be calling multiple LLMs. And then finally, the agents. So anything that's acting on, one, acting to the LLM, helping to connect to the LLM, or acting on the response of the LLM. Okay, so now how does this relate to LangKit that we talked about earlier? Well, it turns out that we're already integrated into the LangChain package. So you've already downloaded WhyLabs LangKit in your download of LangChain. So we see here that there's a WhyLabs callback, and this WhyLabs callback is in LangChain, which allows you to very simply set up using LangKit while you're using LangChain. And we're going to see code in a little bit, but first let's look at some on the slide to kind of understand. So, so what do you do? So when you import LangChain, you can also import the WhyLabs callback handler. And then when we're calling our OpenAI method here, or class here, I believe, we can pass in all of the stuff that we're used to. So temperature, later we would pass on a prompt, so on and so forth. But then we're passing in a list of callbacks, including the WhyLabs callback. And this is all you would need to do so. Okay, let's go ahead and, well, I'll do a quick summary and then we'll jump in. So again, WhyLogs is the open source package that we use to do that kind of statistical profiling and to create the telemetry that we pass on. Yeah, let's jump in to the demo here, and then we're going to jump back into that. Okay, so again, there are links in the description about how to get to this demo yourself if you want to run it in parallel with me. But let's go ahead and get started. So the first thing that I'd ask you to do is go to open a free WhyLabs account. And so there is a link, I believe, also passed around here. So whylabs.ai/free. And when you go to that link, You can click right here on Get Started for Free and sign up. I'm already signed up, so I'm going to log in here. But sign up is very fast, typical of internet things. So your email address, and then you'll get an email to authenticate that, and then you'll be able to log into your account. So I'll walk you through the account a little bit here. Oops, too big. Okay, so what we see here is our organization. You won't quite have any resources here yet. So what you can do is actually click on the global demo organization and see some examples of models that are already up and running. So for example, we're going to look here at our demo LLM chatbot. So when I click on this, I see a number of things. I can see that there are 47 data profiles that were uploaded for this, and that it's an hourly model. Many different information about the health, the different metrics that are available in our data set, and so on. So what I like to do is actually start here with Explore Profiles so that I can click on the right range of data here. So this is an older model that we're going to look at here. And we are in our Insight Explorer. So this both tells us a little bit about the profiles of data ourselves, so the statistics that are being captured. And so we can see prompts, we can see responses, and we can see many, many different metrics that are automatically captured using LangKit on top of our prompts and responses. And if you click into these, we can see our distribution here, box plots, some example data if you've chosen to set that up, and so on and so forth. Okay. The last thing I'll show really quickly before we get into our creation of this data by hand is that if we go into dashboards, when we're specifically on an LLM model project, we can see different things. So we can see this dashboard here for security and as well as performance. So in our security dashboard, we see things like has patterns, which is going to tell us about the data leakage in our model, jailbreak similarity. So this is, for example, the 99th percentile of the similarity score, the cosine similarity score of the text that is being passed in for prompts. So we see the same thing for response below, but for our prompts, 2 known jailbreaks. So what we see here is that even the 99th percentiles, so even the top 1% of most concerning prompts are not terribly similar to a jailbreak attempt until this last day, where we see a higher percentage similarity to jailbreak attempts. So this is something that's worth noting and something that we caught, within that hour. Similar for different other things. So sentiment, for example, we see fairly neutral but positive sentiment throughout this time, and this is for the mean. And then the mean sentiment drops precipitously. So this is saying that the sentiment really has dropped in this last hour somehow, and so on and so forth. And toxicity, unsurprisingly, has gone up right as the sentiment has gone down. Okay, so these sorts of insights can be really helpful, and kind of the importance of this monitoring process for your LLMs. Okay, so let's, hopefully you are able to have gotten into your account by now. And what we'll need to do is go to our settings here. So click on this hamburger menu, settings, and you can go to access tokens down here. And if you don't have one, I do. If you don't have one, you can create an access token here. So give it a name. If you would like, give it an expiration date and hit create access token. And you can save this because we're going to use this to do our demo. And I think you will want to make sure that you're on your organization that you have control over, not the demo. So I'm going to go here, then go to settings. Oops, not user management, access tokens. And then you can create your access token. Okay. So once you've done that, we will get back to our notebook here. And just to test to make sure everything's working well, we have our hello world, of course. For those who aren't familiar with Jupyter notebooks or Colab notebooks, a shift enter will run the cell that you're on and move your focus to the next cell. So the next thing that we want to do is setup. So as I mentioned, the LangKit callback is actually already included in LangChain, but we're going to log into these separately because I want to show in a little more detail how these things work. The very last couple of cells of the notebook allow us to do it the fast way, but I want to do it the slower way so that we can understand actually what's happening and show how to exert some more control over the metrics that you select. So if you run the cell to pip install LangKit with the all extra here, and then pip install LangChain. And this is going to take probably a minute or so. So I will give you some time to do that. Okay. As it's running, as I mentioned, you should grab your keys that you just received from the WhyLabs platform. So I like to store them in a text file on my machine. So I'm going to go ahead and grab those as you are installing the imports here. Okay. So once you have your key and you have it copied here, there's a couple of things that we need to do. We just need to set environment variables. So hopefully this is run. If not, give it a little bit of time. But then what we're going to do is we're going to set a couple of environment variables that we need to run through this demo. So there are 4. The first one is our default org ID. So this is the name of the organization ID. The way that we can find this is if you go back to our WhyLabs platform here on project dashboard. Again, make sure that you're in the My Organization and not the demo org right now. There's a couple of places you can see it. So it's actually up inside of the URL if you want to copy it from there. But I find that the easiest way to see it is actually to go to settings. And then I believe in access tokens, right here, we will see our organization ID highlighted in a little gray box, rounded box. So what I'm going to do is I'm going to copy this and paste it in when we run this. The next thing that we need is our default dataset ID. So let me actually show you where to get that as well. So if I click on WhyLabs, I can create a new resource for our new model. So I'm going to hit create resource. I'm going to give our resource a name here. I'm going to delete one of my models first, just so I have some space. So we're going to give this a name. So let's call this LangChain plus LangKit. Actually, no plus. Let's just do LangChain LangKit demo. And we are going to make this a large language model resource type. We'll only add one. Daily is fine, since we are all using the free plan here. And then we're going to add models or data sets. Okay, so what we see here below is that it's been given an ID of model 31 in my case. In your case, probably model 0 if you've created this new. So that's what we're going to pass in down here. And then, so actually, let's go ahead and run this. We'll do this one at a time here. So I'm going to copy in my organization ID. I'm going to copy in my model number. So in my case is model 31. Yours is probably different. I'm going to copy now my API key. So this is what I copied, what I created when I created my access key. And it doesn't show up again. So if you didn't get a chance to save it, you can go ahead and create a new one. So in access tokens, and just create a new one if you'd like. But hopefully you were able to save it. I was able to save mine, so I'm going to copy this over as well. And then finally, any OpenAI API key you have. So this will allow us to actually call OpenAI to run that particular demo. If you don't have an OpenAI API key, that's totally okay. We can leave this empty for now. But I do. Okay. So I have a question here. I'm happy to take it. The question is, so LangChain can combine some models. Does that mean you're taking the final result? And that is up to you. So there's different ways that you can think about combining models. One is taking the responses. So often in LangChain, you will either call the models one at a time. So I might call a model and have some sort of function that determines whether or not I'm happy with that model. And then I may call a backup model or so on and so forth. So in that case, right, I'm taking the response of the last model, the one that I was happy with. But there are other situations in which you may want to call multiple models at the same time. And then it's up to you on what sort of logic you want to do with those different responses. Maybe you want the shortest response, or maybe you want to combine them somehow yourself, but you would do that in a kind of custom way. Okay. Hopefully this has worked for everyone here. So we have our environmental variables. Let's go ahead and get started. So the first thing that we're going to do is we are going to import LangKit, but particularly the LLM metrics module. So we have a number of packages of metrics that can be helpful to users. LLM metrics, I think, is the more standard one. If you have a maybe slow machine or just want to get through this quickly, light metrics is much faster. So it will get rid of some of the more expensive metrics that we have that rely on language models themselves, but still be quite helpful in determining things like data leakage and other like readability scores and other things like this. And finally, we're going to import WhyLogs. So WhyLogs, again, is this open source package that does this statistics collection for us, this telemetry. So once we import these two, maybe I should have separated them in lines, we can initialize our LLM metrics here. And this will take a little bit of time, but what this is doing is downloading all of the models and information we need to just prepare to collect metrics. And so this is kind of a setup and getting everything spun up so that things are hot when we're actually calling with metrics. Okay, we'll not go with the custom snippet here or the custom widget here. Okay, so once we've imported this, you'll see that we've stored our result of our initialization in schema. So this will be passed into calls to WhyLogs so that we can know which metrics and which schema to use for collecting of these statistics, particularly for LLMs in our case. Okay, so now we can call y.init. And what this is going to do is help you to find the right session. So if you've inserted your session information correctly, this should work well. It should initialize a session, type WhyLabs with the information that we passed in. If this for some reason didn't work, you're welcome to, it might ask you a question of one or two, to use WhyLabs info or to use an anonymous session in WhyLabs. Feel free to type 2 if that's the case. Okay, so let's get further into our demo here. What we're able to do, now we're able to download some data. So we, before we get to the OpenAI example, I just want to show some data that we've already loaded into the package so that you can play around with it. And this is a lot of stuff in one cell. So I'm actually going to delete this one first, just because I want to show you the data itself. You're welcome to run this all at once. But so what we can see is that we've loaded some chat data. And there were 50 records in our data. And then we're showing the first chat. This is actually right here. Let's push this up a little bit. This is actually just a data frame of 2 different text fields. So one being the prompts and one being the responses. So these are real responses that were received, I believe, from GPT 3.5, although my memory is not serving me well right now. And so you can see many, many different chats here, and we have 50. So these are prompts that were collected from the internet or generated by the team, and then responses from the chat GPT. Or GPT 3.5 particularly. Okay, so how do we use WhyLogs? So again, WhyLogs is what's going to capture these metrics for us, and LangKit is what defined some of these metrics specifically for LLMs. So what we can do is y.log, pass in our chats data set, pass in our schema that we initialize our LLM metrics with, and then just give it a name. Oops. So the name right here is LangKit sample chats all. That's totally fine. If I run this, it's going to go through all of these lines and log all of the metrics that we talked about and thought about for our model. Okay, so we see that we aggregated 50 rows into this profile, and now we can click on this link that was given to see that profile. So we see here, we're launched right into that insights page. I apologize, this is a little small now. And we can see many things. So we can see all of the metrics that were passed in. So despite the fact that we only had prompt and response, we see the many metrics that were calculated on top of that, including character count, difficult words, reading scores, things like finding social security numbers and mailing address and phone numbers and credit card numbers inside of the responses, which can be a concern. And we have many insights here. So if you see this insights, we can see many things that were flagged as possible issues into our data, or just insights into our data. So things like our prompts, including some mailing addresses and 2 examples, a high jailbreak similarity score of 0.31, which isn't too bad. A reading ease score of 58 out of 100, which implies that some of the responses from the LLM are difficult to understand, refusal similarities, that sort of thing. Okay, so we just used LangKit for the first time. This is awesome. Now let's start thinking about using it with LangChain. So for those who are familiar with LangChain, you've probably seen something like this before. Again, there's many, many different ways to use LangChain. But what we have here, I'm going to import a number of different tools in LangChain: chat prompt template, system message prompt template, and human message prompt template, and a couple of schemas for messages. So what are we creating? So in this example, we have, we're trying to use an LLM to rewrite user text into more happy and upbeat text. So what we do is we're writing a template using a system message here that says exactly that, telling the LLM what the context here. And then we're going to pass in the text from the user. So we're just going to, in our case, just pass that directly, passing on our text. But in many other production cases, there's a lot of complexity to how we're going to generate this text. Okay. And then from there, we can use our LangChain.chat models, chat OpenAI, and assign that to our LLM variable. Okay, so now we can create a function here to take our prompt, take our template, and we're going to pass the new prompt from the customer, for example, into our LLM function and print the response, and format the response a little bit and print the response. So let's define that function here. And let's just give an example. So one example is, I don't like Mondays, or Tuesdays for that matter. Today is Tuesday. And although I'm a fan of Tuesdays, but we'll see what the LLM says. And then we're going to pass in our template, which we named template upbeat up here, and run this. So I think I might be calling this in a slightly old way, but this still works for us here. And so we can see our prompt and response is slightly more upbeat. I'm not a big fan of Mondays or Tuesdays either. That's slightly more upbeat. Okay, so that's what we can do with LangChain. This was just an example of how to use LangChain individually before we think about combining with LangKit. So one option that we can use is actually to use WhyLogs to take our LangKit schema, kind of like we've done in the past, and profile in the same way that we've done in the past. I won't do that here. I'm going to kind of jump into the combination of these sorts of things. One thing it might be worth noting is that if we run multiple prompts here, this is easy to do. So we're just going to make a loop here where we track. Oops. That's what happens when I don't run everything. So we can take our prompt and response. We can create a new example here. And then we can both look at the sort of data that we see inside of our profile, but then also add more data to that. So I'm going to just do that here. Okay, and then we see this profile has extended. So now we have 4 responses and 3 prompts here, and many statistics on top of that. You could look further into this. So it's worth noting that these profiles themselves contain many different metrics that are accessible individually. So if I wanted to go and get the response.aggregate reading level column and grab the maximum from the statistical distribution of the data, I can capture that. So this is the max response reading level. And we talked quite a bit about WhyLabs, but let's go ahead and look right here at the code. Again, we saw them in the slides, but the code to do this all much more simply with the LangChain callback integration. So again, what we can do here is the WhyLabs callback handler. We're going to import that. We're going to import OpenAI. And now we can set up our callback handler here with the just default parameters. And then we're going to create an OpenAI class here with a temperature of 0, and then our callback for WhyLabs. And now we can do the same sort of thing, but much faster. So we're going to go LLM.generate, which is a LangChain function, but that is going to be using this callback. And we print the result here, and then what we use is WhyLabs.flush. So this happens every 20 minutes, but we don't have 20 minutes to spare right now. And this has uploaded a data set. Cool. So this is the whole demo. Feel free to check this out here. So we now have many different profiles over here at WhyLabs. Please do check out the tool, and feel free to hopefully use LangChain and LangKit together much more easily. And if you have any other questions about how to monitor LLMs, how to think about monitoring complex LLM setups, happy to chat about that. Thank you.